Hello guys. In this lesson we will learn about the inverse of a quadratic function, how we can find the inverse of a quadratic function, and how can we restrict the domain of a quadratic function so that the inverse of a quadratic function is also a function, because the inverse of a quadratic function over the all set of real numbers is not a function. Okay, so the first question is, I've given a quadratic function in the vertex form and I have to graph the function and its inverse. So graph it, what I will do, I will find the vertex here. So my vertex is -3, -4. Okay, so once I have my vertex here, I just plot the vertex, which is -3 and -4. So that's the vertex. And now I have to look my step pattern. The step pattern for the parent function is 1, 3, 5, and so on. Okay, but here, because there's a vertical stretch by a factor of 2, so I multiply all these numbers with 2. So when I multiply with the numbers with 2, I will get 2, 6, 10, and so on, right? So I will start from my vertex. I'll go 1 right and 2 up, and then 1 right and 6 up. So it's here. Similarly, I go 1 left, 2 up, and 1 left, 6 up. So that is the graph of my function. Okay, and then I just plot it. Okay, before I graph the inverse, I will just state some of the properties of this function. So when it comes to the properties, the first is, what is the vertex? So as we just did, the vertex is -3 and -4. Next is, what is the equation of axis of symmetry? So axis of symmetry is, is this line, right? So equation of axis of symmetry is x equals -3. Equation of axis of symmetry is always this number. Okay, and now the direction of opening, and you can see the direction of opening is upward, right? Because my a value, this is my a value, right? A value is positive, so the direction of opening is upward. Okay, when your graph open upward, this is a minimum, right? Your graph has a minimum value. When your graph open downwards, it has a maximum value. Okay, so here as my graph open upward, I have a minimum value. And what's my minimum value? Minimum value is always the y value, which is -4. Okay, and we can also talk about the zeros here. Zeros are these points where my graph crosses the x-axis. This is also called zeros or x-intercepts or the roots of the quadratic function. Okay, so these are some of the properties of the quadratic function. And now I will graph the inverse. So how will I graph the inverse? So I can just flip the points. So example, I'll take these points. So this point was, this point is -3 and -3, -4. So when I flip that, that will be, okay, first I just write the coordinates of the point. And this point is, x is -1 and 4. And this point is, x is -5 and 4, right? So when I flip these points, my new points will be, okay, when I flip that, it will be 4, -1. This point will be 4, -5. And this point will be -4 and -3. Okay, now I will plot these points. So when I take these points, -4, -3 is here. So that's my point. Then I have 4 and -5. So x is 4 and y is -5. So -5 is here, right? And this point is, x is 4 and y is -1. So x is 4, y is -1. So that's the point, right? And now when I graph the inverse, -1 is not here. Give me a minute. -1 is here, right? Okay. -1 is this point, right? And now I graph it. So the inverse function will be like that, here and here. Okay, so once I graph the inverse, you can see that the inverse is not a function, because if I graph a vertical line through my graph, it passes the graph at two different points, so it's not a function. Okay, the next part is determine the equation of the inverse. So how will I find the inverse? So first I write my equation. My equation is f of x equals 2x plus 3 square minus 4. Okay, so we know what are the steps to find the inverse. The first thing is I replace f of x with y. So y equals 2x plus 3 square minus 4. Second step, I switch the variables. So it will be x equals 2 y plus 3 square minus 4. And the next I have to solve for y. So what I will do first is I will move this 4 to the other side, right? So it will be x plus 4 equals 2y plus 3 square. And now, before I take the square root, I will divide both sides with 2. So I'll divide this side with 2 and this. So here 2 cancels out, and I'm left with x plus 4 over 2 equals y plus 3 whole square. To solve for y, the first thing I will do, I will take the square root to get rid of this square, right? So when I take the square root, it will be square root of this and square root of this. And when I take the square root, I write plus and minus. So I'm left with y plus 3 equal plus minus x plus 4 over 2 square root. And now the last thing is I have to move 3 to the other side. So I can do plus minus x plus 4 over 2 minus 3 equals y. And finally, that's my inverse. So I can write f inverse x equals plus minus x plus 4 over 2 minus 3. So that is my inverse function. Okay, the last part was the restricted domain of f of x, so that the inverse is also a function. So whenever you have to restrict your domain, so make a rough sketch here. Here we already have the exact sketch here, but if, for example, I'm taking the question from here. So if I have to restrict the domain, what I will do, I'll make a rough sketch. I know my vertex is minus 3 and minus 4. So minus 3, minus 4, right? So if I just make a rough sketch for that, x is minus 3 and minus 4, say that's point, right? And I know because my a value is positive, so graph open upwards. So graph is like that, right? Okay. So if I want to make sure that my inverse is also a function, I have to take one branch of my graph, right? So if, for example, if I pick this branch of my graph, and you know my x value here is negative 3, right? The point is negative 3 and negative 4. If I'm picking this branch, so my restricted domain will be restricted domain is x belongs to R such that x is greater than or equal to negative 3. So if I take this branch, this is my restricted domain. And if I pick the other branch, for example, if I pick this branch, if I pick this branch, then for this branch, the domain will be x belongs to R such that x is less than or equal to negative 3. And just to let you know that for this branch, my domain is this. Okay, so you have to restrict one of the branch. You can have only one branch to make sure that your inverse is also a function. So it's always a good idea. So just make a rough sketch so that you can know what's the x value of your vertex, and you have to restrict either you have to put the restriction on the right side or on the left side. Okay, so that's how we can restrict the domain of a function, of a given function, so that the inverse is also a function. Okay, thank you so much.